for students over here, I think it's 80, right?
Yeah.
Okay. So okay, there is a common mistake for this kind of question is they can give you 80, but you still have to read whether it reaches 80 or not. Okay.
Oh.
Yeah. Some cumulative frequency diagram, right? They can give you until 100. Like let's say they continue to give it to you, like they give you 90, then they give you
Oh, yeah,
100,
yeah.
and you
But they're
don't
not part of the graph one.
yep, and then you don't assume that, oh, if they give you until 100, that means you take 100 divided by 2. That's the median. No. No.
Okay.
Okay. So you always look at where your cumulative graph ends, and then from there, half of this. So therefore, this is 80. So half of it is 40. Yeah? Over here, this point. Yeah. Okay.
Yeah.
Hmm.
Then interquartile ranges.
1/4 range, then 3/4 range.
Is it just 4 minus this 2.3?
So it's the 20. It's the 20 and the 60. So it's the 20 here. So this value. This is
And
your
the 4 minus it, right?
then this one. Yes. Correct. That's the interquartile range.
The gain up to in the first month.
So questions like these are the low hanging fruits. So
yeah,
the easy pickings. So you have to grab it. Yeah.
estimate that.
They say what NB 0 to 5 kg diapers in a newborn. Oh, they talk about this. I just had my newborn. What is it? Newborn less than 5 kg. Oh, okay, 64 pieces. Wait, just 1 kg in their first month?
Yeah.
Let me think about mine. Oh, yes, it's about 1 kg. Yeah. Yeah, it's about 1 kg in the first month.
Minimum percentage. So it has to be above 5, right?
What does that mean?
Wait.
So it's going to be gain up to 0.9. Actually, it's 0.9. So using the cumulative gradient at the below probability, estimate the maximum percentage of babies who may not fit into newborn size at the end of the first month.
So it's the 4.1 kg, right?
What do you mean by
4.1 and below. Because if they're born, no, 4.1 and above,
Yep. Yes.
then they wouldn't fit.
Yes. Yep. So
So
how many of
just
them?
20.
20 of them? Yeah. So the cutoff is the 4.1 here, right? You're talking about. This is not. This is 62 years. Yeah. 18 of them, right? 18 of them, right? Right? 80 minus 62, right?
Alright.
I was using your number.
Yeah.
Yeah. Ah, I should get a line here and then just park it.
It's just 18.
Okay. So you use the median to compare, right? Okay. The newborn baby are heavier compared to wow. Why so? I don't know whether this survey or this statistics is true or not. Why the 1990s babies were heavier compared to babies in 2020? Pandemic? Okay. Okay. Oh yeah, makes sense. Okay. Oh. Ah, okay. Okay. Mm. Yep. So about the same way, you need to talk about the interquartile range, lah. The less, the better, right? The less means like they are more or less the same weight. Yeah. Yes. Hmm. 4 minus 2.3. Oh, okay. Hmm. Okay. What's the ECF? I think I think they will not give you the error carry forward. Yeah. Yeah, I know. Yeah, yes, yes. In fact, like basically this is the ripple effect of your mistake at the start. Yeah. Actually, I don't I don't think so anymore, because because I think they will give you some consolations, like probably like if you don't, let's say instead of losing 5 marks, probably they give you 1 mark. I don't know. It's like a leniency mark. But I don't know. Actually, I don't know. But error carry forward. I don't think is happening anymore. Okay. So when it comes to questions like this, if you know that the later part, let's say this part, has to use answers from the first part or the second part here, then you make sure that your second part is correct. Okay. Mm. Because the logic is, if you make a mistake, you should correct the mistake before you move on. If they allow mistakes to be carried forward, that means mistake gets bigger mistake. And no, that's the reason why I asked you to make sure that this answer must be right. Actually, this error carry forward, right? This is so morally wrong. Like if you make a mistake, then you continue, then you're allowed to continue to make the mistake. That's like, it doesn't make sense to me morally. Like what subject? Uh huh. Yeah. Yeah. Mhm. Oh. Oh yeah, yeah, yeah. You see, okay, wait. Reasoning, they give you score. Okay, I understand you already. They give you score for your reasoning. Okay. Yeah. So basically, your reasoning is correct because based on your answers, your reasoning is correct. But your answer is wrong. But mathematics, you don't have, you don't get to explain your answers. You mean over here? Then this one will be so arbitrary. Like if subjective, it depends on that teacher, the examiner. Yeah. So you don't want to leave it to chance. Yeah. But my advice to students is like, if you know that this part is linked to the first part or the second part, you make sure your previous part is correct. Okay. Good. Wow. So fast. Wow. I can't believe our speed. 19 pages, like, come on. I don't think we feel. Did we do this logarithm question? Really? Question 3. Oh, okay. Let me just walk through it. Oh, one page, one question. Yes. Right? I don't think we want to do the probability one. The probability looks very easy. Yeah, like the probability tree and all those. Hold on, I'm just walking through all the pages also. Actually, I have a question for you regarding this kind of this polynomial. I'm just I'm just wondering how you use the hands to solve it. So I'm going to show you the question now. They ask you to use the hands, not otherwise. Otherwise, it's very easy to solve, but hands. I don't know. Maybe you can let me know how to solve it using the hands. And I will tell you what I observe. Okay, I have uploaded this. I think this kind of question is very common for polynomial. Okay, so I just give the answer for you for part B. So you are asked to solve this. A is okay. So I just give you the A lah, huh? Because this student has solved it already. Is 4. Okay, so you will get this. And then the factorization gets you this. So therefore with this then you get your x equal to 4, x equal to minus half, then x is equal to 1. Okay? Okay, so now with this they ask you to solve the below one, hence. So the hence part is this 4x3. Use a different color. No, we don't care about a equal to 3 because this is correct already. So I'm telling you, this, solve this cubic, you will get this. Okay. Anyway, solving cubic equation, if you have a powerful calculator, you can just use the calculator. But now my point is how to use hands to solve this. I'm not sure if you observe you observe this or not. I hope you do. Okay, so the 4 here, right, actually comes to this, the front part. And then the 3x comes to the 3x squared part. And then the minus this one comes to this. So the x cubed becomes here. So how do you use the hands to solve it? Hmm? How do you use the hands? Actually, if I rearrange this, it will be this one. I rearrange this. So how do I solve this? They ask you to solve the equation given this 1 mark. So I mean, like, you should see it straight away, that kind of. Is it this? So 2x plus 1 is actually 2 plus x. Then this is 1 minus x. Then this is 1 minus 4x. Does this make sense? This one? Yep, yes. This is minus 2. Then this is 1. Then this is 1/4, right? Can you help me out with a calculator? So what do you get? So that's how I can quickly confirm. Nice. Okay. So yes, so by observation. Wait, they use hands. Can you see the word hands? No, it's about hands. If they ask you to use hands and you go use otherwise, you don't deserve any mark. Okay? Hands means hands. You use otherwise, wrong. Okay? But good that we talk about this question here. Okay? So what I observe, like I say, what I observe is the is 2 minus this. Okay? And then just flip the coefficient, like you say, flip the coefficient. Okay? Okay, good. Let me see if I have another question here. I think I have. I have plenty of questions here. My students love asking me questions. They basically they want me to do all the heavy lifting, and then they just do the low hanging fruits. But okay, yep. I like it. Okay. Let me share with you this trigo question. Because I just want you to actually we talked about it the other time. I just want to emphasize this one more time. You remember the trigo question? So there are the exact value type of trigo questions. Okay. So one of them is you have to draw it out to use the Tokaso. Then the other one is special angle, right? Can you recall? That? Okay, good. Let me just zoom in. So I'm talking about question 11 here. Okay. So for question 11, right? Actually, I think your approach is to get the actually for me, right? Okay, let me do it my way first. Okay, so I will use the quadrant. All science teacher are cool. Then they say the A is in the 0 to 180, so it's here, right? So it's in the S region, right? Because it cannot be in the A region because tangent is negative, right? So gone, right? So now, what I will do is actually the quadrant will give you the sign. Okay, and then you will have the magnitude portion, and the magnitude portion is given by the Tokaso. That's how I would like to look at this kind of question. So with this understanding, I just draw the tangent 3, 4. So this is A, right? Then it's O over A, so this is 5, right? So this is the Tokaso, the right angle triangle I'm going to use for the magnitude. Okay? So I don't have to care about Because the other time I remember you say draw to the, like, if you draw to this side is -2, and then you go up is +3, you know, that kind of thing. I don't have to care about that, you know. You understand me? You understand me now? Pardon? Magnitude is always positive. Yes, yes. Magnitude is just the yeah. Magnitude is the value without the sign. Yeah. It can be. It depends. Like that. That's why I say. This is what I say. The sign is determined by the quadrant, and the magnitude is determined by the Tokaso. Yeah. Yes. 1/sine. So let's do it together. Okay, let's do it together. So it's 1/sine A, right? That's our cosecant. So sine. Okay, so let's figure out what is sine A first, right? So sine A is O/H, right? So you flip it, will be 5/3, right? So this will give me the magnitude. Okay, and then I ask myself, the A is in the what region? It's in the S region, right? So for sine is positive. So yes, so the sign is positive. So of course you need to get it into the proper fraction. So it's 1/1/3. Does it make sense to you? So what I'm trying to tell you is, instead of using your approach, or I don't know, I love the simplicity of this approach. Okay, because sometimes it's very confusing. Like, why I get a negative, then why I get a positive. You remember? You remember the other time? Yeah. So that's why not we just, okay, the quadrant will take care of the sign. So if you want to know the sign, and by the way, you always need to ask yourself, what sign? So in this case, the sign will be taken care by the quadrant, and then the magnitude will be taken care by the Tokaso, which is the right angle triangle. So I hope by doing this exact value question this way, you will not get the sign wrong. You understand my point? Let me tell you why. Because if it's in the tangent region, right? If in the tangent region, you know what are you going to draw? You're going to draw this -3, and you're going to go down like this is -3. You understand my point? And then once you join is when you have -3 and -3, and then you're going to end up with positive. It's very hard to understand. You understand why it's hard to understand, no? Yeah. So that's the reason why I really want my student to just, if you want to talk about the sign, just get the magnitude out first by using the Tokaso right angle triangle. If you want to know about the sign, ask the region or quadrant. Alright? Okay, good. Yes. So I think we had a very good session, and then that properties of circle, that question is really yeah. Alright, but so something we can learn from there is, first thing, zoom in and out. Second thing, do it on paper. Do it on paper. Yeah. Okay? Yeah, there's something magical about pencil and paper. Okay, so let's see if I can fix my camera next time. And I will see you next time, alright?